this recording we'll discuss fluid imbalances. So imbalances of fluids really kind of come in two categories. We've got dehydrations and overhydrations. Now, dehydration is probably what we're most familiar with, but you may not know that there are actually different types of dehydration. But just generally speaking, dehydration is decreased volume and increased concentration of solutes in the extracellular fluid. So basically your water intake is less than your water output. Okay? Now again, these come in different varieties. So hypertonic dehydration, you are losing water. Hypotonic dehydration, you are losing sodium and other electrolytes. Isotonic dehydration, you're losing both water and sodium. Okay? So, depending on which you are suffering from will depend on what's happening to your cells. They could shrivel or crenate. They could swell. If they swell enough, they could lyse or they could pop. Okay? Or they might not change much at all visually. Okay? Just depends. So, here we go. Isotonic dehydration is equal loss of water and electrolytes. This is the most common form of dehydration. This is also probably the one you are most familiar with. This is the least fatal because we are not moving fluids across any of the membranes. Okay? So how do we get isotonic dehydration? One instance of diarrhea or vomiting. Okay? And again, the one instance is very important because if you had continued diarrhea or vomiting, then you could actually end up with hypotonic dehydration. That's a completely different case. All right, so you literally got sick once. Okay, temporary fasting, okay, or one instance of bleeding/hemorrhage could be internal or external. Okay, and again, this is one instance, like whatevs. Because if it's continual, then this could end up as being hypotonic dehydration. Okay? Now, again, what are we most familiar with? We're most familiar with the diarrhea, the vomiting, or even perhaps the fasting. Okay, again, you got sick once. Something upset your stomach once. Here's kind of what happens. We are going to talk about hypo and hypertonic here in a second, but right now we're focused on isotonic. So P is plasma, IF is interstitial fluid, okay, so your extracellular fluid. C is your cell, so your intracellular fluid. Notice that we have no arrows like we do on our other two pictures here, indicating that we are not having net water movement in one direction or another because we are losing both water and solutes. Okay. All right. Now, hypotonic dehydration. Okay. Sometimes you'll hear this referred to as hyponatremic or hypovolemic dehydration. If you are suffering from hypotonic dehydration, you are losing the salts, the solutes, or the proteins from your blood. Okay. So you're not really losing a whole lot of fluids. You're losing salts, solutes, electrolytes, proteins, that kind of stuff. Now, proteins, in the blood. What does that do? That's your BOP, remember? Okay, your osmotic pressure is lost, okay? Or your hydrostatic pressure is gained. I know, and that's kind of blowing your mind, right? Instead of losing a lot of salts and things like that, perhaps we are instead kind of gaining a little bit of fluid, and so it seems like we don't have as much salt. Okay, food for thought there. So if we are losing our BOP or if we are gaining hydrostatic pressure, fluids are going to move. Okay, so net movement. Fluids are going to move from the capillary plasma, so we're going from the plasma into the interstitial fluid, okay, which will cause edema, and then that fluid will continue to move into the cells, intracellular fluid. This is going to cause the cells to swell, okay, and again, if this goes on too long, the cells might lyse, They might bust open, which basically kills them. That's bad. Okay, so how do we do this? How do we get here? Hyponatremia. Okay, so again, your body thinks you don't have enough sodium. Okay? A hypotonic drip. Okay, water intoxication. Right, so now we're just putting too much water into the body instead. Nephrosis, which basically causes you to lose proteins through your urine. An infection or inflammation, so proteins would end up in your interstitial space instead. Severe burns would cause loss of proteins, like in your skin and things. Severe diarrhea and vomiting. Okay, so again, we previously mentioned one instance of diarrhea, one instance of vomiting. That was isotonic, but if it is severe, okay, this causes a loss of sodium from the blood, okay, and other electrolytes. A lymphatic obstruction. Again, we're going to have proteins that are going to be lost in the interstitial space. Liver disorders, loss of proteins from the blood, because now your liver is not even making them. Diuretics cause the inhibition of sodium reabsorption. And hemorrhaging or bleeding causes a loss of proteins and stuff as well. Okay. So here's our picture. We are on hypotonic. Dehydration. We're going to have fluids move from the plasma into the tissues and cause swelling, and then into the cells, which also causes swelling, perhaps lysis. Okay. Now, hypertonic dehydration or hypernatremic dehydration. Okay. You are either going to lose water, okay, or you're going to gain salts, proteins, electrolytes, things like that, okay, from the blood. So here we've got the opposite. Your hydrostatic pressure is lost or your BOP is gained. Okay, so if you're losing water, your hydrostatic pressure goes down. If you gain salts and proteins, your BOP goes up. Okay, one or the other. This causes the fluids to move from the cell, okay, into the tissues and then back into the plasma. So the cells are going to shrivel up. They're going to crenate. Okay. So how do we end up with this? Could be hypernatremia. Okay. Drinking seawater. Okay. Please don't drink seawater, even if you're desperate. Okay. High salt diet. Okay. Hyperaldosteronism. Okay. All of those things would increase your sodium. Okay. Diabetes insipidus, that one's actually a loss of the fluids. Diabetes mellitus is also a loss of the fluids because you pee all the time. Okay. Fever, which promotes sweating, so that's more loss of water than salt. Okay. And then sweating, same thing, loss of more water than salt. Okay. And here's our last picture. Now we're going to have fluids move from the cell into the tissues back into the plasma. So these cells will shrivel up. Okay. Alright, so those were dehydrations. Now you can be overly hydrated. Okay. This causes an accumulation of fluid in your intracellular space. Okay. And that's not intracellular, that's intercellular, so your interstitial fluids. Okay. This causes edema, ultimately. Okay, so you'll suffer from swelling. This is caused by increase in permeability of your capillaries, since the fluids leak out, but they aren't as easily returned. Okay. We do have anti-inflammatory drugs that block fluids from leaving the capillaries, which reduces some of the edema, reduces the swelling by keeping the fluids in the plasma where they belong. Okay. Now, if we really overdo it on fluids, we could suffer from hypotonic hydration, also known as water intoxication, if your extracellular fluid has excess water. Okay. Your sodium could still be normal. Okay, but that excess water basically dilutes your interstitial fluids, makes it hypotonic. Okay, and if your interstitial fluid becomes hypotonic, then some of that water is going to enter your cells. The cells are going to swell and they could lyse. Okay? So again, if you put too much water in your body, it's going to end up in your tissues and it's ultimately going to end up in your cells and they could swell and they could bust. So here's the interesting thing. Your blood pressure appears to be normal. Okay. Aldosterone and ADH are inhibited and urine output increases. Okay. Increased capillary hydrostatic pressure and permeability causes an increase in filtration. Okay. If we could have a blocked venous valve, okay, or just a blocked blood vessel. You could be suffering from congestive heart failure. You could have an extra high blood volume, an ongoing inflammatory response. Any of those can cause the capillaries to become more porous than normal. Okay. This could also come with hyponatremia, and if that happens, it also promotes edema, which would further cause water to go into the cells even more. Okay. The hindered fluid return tells us that we have an imbalance of your blood osmotic or your colloid osmotic pressure on both sides of the capillary membranes. The proteins are going to leak into the interstitial space, which they're not normally there. That also promotes the edema. Okay. The hyperproteinemia forces fluids out at the arterial end, but we are reducing your BOP, and so they don't, that fluid doesn't return. Okay. And then the venous end could also be blocked. Perhaps you have removed lymphatic vessels as well, and so that fluid really doesn't have much of a choice, but it just kind of stays in your tissues, and that's where we get some of that edema as well.